Good morning, everyone. Sorry, good afternoon, everyone, and welcome to this lecture. We were dealing with Newton's laws of motion, and I think we have come on to Newton's second law. Newton's second law tells us whenever there is a force or the rate of change of momentum is directly proportional to force, and it takes place in the direction of force. Whenever momentum of a body changes, only force can change the momentum of a body. Only force can cause acceleration. Acceleration changes velocity. Because of change in velocity, the momentum changes. And we had seen an example where we had found out the acceleration of the body. We had seen the formula for acceleration, net force divided by m. We had seen a question where the body was free to move. It could move anywhere. We found out the net force and we divide the net force by the mass. I did it in two ways. I found out the net force by vector addition. I found it by the coordinate system. Both are vector additions. In first case, I simply found out the magnitude. In the second case, I first found out the vector. Then I found out the magnitude. Do we remember this? Yes or no? Now remember, bodies are not going to be free all the time. Bodies are not going to be free all the time. Sometimes they might be constrained. When I say constrained, that they cannot move in any particular direction. They have to move only because of they are put in certain conditions. For example, if you have a body, if you have a floor like this, and you have a body placed on the floor like this, the body cannot move like this because the floor comes in the way. The body can only move along the floor. That means the body is not free to move in any direction that it wishes. If you attach a body to a string, it can only move like this. It cannot just move in any direction that it wishes so. So basically, if we come across those bodies, we will have to, again, we will apply Newton's law. Again, we will apply Newton's laws of motion. But again, we may not be writing F is equal to ma in vector form, but we might have to resolve forces along 3 or 2 different directions. 3-dimensional problem will not come. Along maybe 1 or maybe 2 directions, and then we will have to find out what is the net force or the net acceleration of the body. We had seen that we can write the Newton laws of motion along different axes also. So rate of change of momentum, or m into ax, will be equal to f into ax. M into ay will be equal to f component along y, and m into az will be the force the component along z axis. We will be using these types of equations now, because the body may not be free to move in all directions. Now, whenever we come across such questions, what we got to do, there is a simple process that we need to follow. It is not dramatically different. How do you find out, or how do you find out the acceleration of the bodies which are constrained to move? So we'll write some steps. We will follow those steps. Once you follow them once or twice, those steps will come automatically. And you can see these steps would be pretty similar to what we had done for the questions on equilibrium. So let us write first thing first. And the first thing that we are going to write is the steps to solve problems on accelerated motion. Steps to solve problems using Newton's second law of motion. Now remember, the bodies will not be in equilibrium. They would be accelerating. Now tell me, what is the first step that you are going to follow? What is the first step that you are going to follow? What will the first step? Anyone?
FBD.
Yes?
Free body diagram, sir.
Yes, we'll have to draw the sketch of the problem. We might not have to draw the sketch because the sketch is already there. So instead of drawing the sketch, we can move on to drawing the free body diagram of the body. Yes or no? This is exactly same as what we had done in the question on equilibrium. Step number 1 and step number 2 are same. What you can do is you can write it in a column wise with equilibrium as well. Same steps are there. Nothing has changed. So in step number 2, what we are going to do is we are going to draw the free body diagram of a body, and we will mark all the forces acting on the body. What will be the next step? Step number 3.
Resolve the forces.
But my dear friend, before resolving the forces, we'll have to choose a coordinate system. So we'll have to choose a coordinate system. We'll have to choose our x-axis. We have to choose our y-axis. There might be some forces which lie on the x-axis and y-axis. Don't worry about those forces. They're already there on the x-axis and y-axis. There could be some forces which are not lying on the x-axis and y-axis. So we only need to resolve those forces. Do we understand this? Yes or no? Okay, what would be the next step? What would be the next step? Once we have forces along x and y, we will not have question where three-dimensional body will move in 3 dimensions. One question we have already seen. The body in most cases will only move along 1 dimension. But let us say that if it is moving along 2 dimension, it is moving along x as well as moving along y. We will write Fx, the net force along x-axis is equal to m into ax. For each body, you have to write this equation. There may be more than one bodies. Remember that. For Fx, the net force along x-axis will be m into ax, and the net force along y-axis will be m into ay. All of us understand this, boys, girls, all of us are together. So as you can see, if you compare it with the steps of equilibrium, if you compare this one, only the 4th step is different. Up till 3 steps, everything was same. Only the 4th step is different. And why it is different? Because in equilibrium, the net force was 0. Therefore, there was no net force, no acceleration. Here, the net force is not going to be 0. And therefore, we will have to write this equation. Do you understand this? Now, let us start with the most simple and the most basic problem. And we'll try to solve it using these steps. Everyone is ready? Everyone has noted this down. I'll give you 1 minute while I draw the diagram of the next problem. And we'll start with the most basic and the most simple one. So that we understand the concept. Are we ready? Yes or no? Then here we go with the first problem. A very basic and a very simple one. You have a block of mass m, which is given as 5 kg. It is kept on a smooth floor. Remember, friction is not going to come until the next chapter. It's part of the same chapter. Only friction will come. You have to find out the acceleration of this block. You must know the value of cos 37. Cos 37 is 4 by 5. Sin 37 is 3 by 5. So having told you the values, let us start with this basic problem. Once you understand the concept, how we are going to go ahead, then all the problems will be done quickly. So I'll give you 2 minutes to do it. Follow the steps, nothing else. Now remember, once you have this body, one thing I need to tell you. How will this body move? Along which direction will this body move? Can this body go up like this? Obviously, this body is not going to go in the air. Do we understand this? Okay, the value that I have given, it might actually go in the air. So let me change the value as 10, make it as 10 kg. The body is not going to go up in the air. Then how is the body going to go? Body is kept on a floor. How is the body going to move? The body is going to move along the floor. Do we understand this? So you have to find the acceleration of this body, assuming that it is going to move along the floor. You have 2 minutes to do this.
Four meter per second square, sir.
4 meter per second square. I've got an answer as well. Well done. That means you have done the question. Let me give everyone a fair chance to try. Everyone has done this? Girls seem to have done this. What about boys? Boys are always behind. No, boys are also coming up. Now let me do it step by step. I'm not going to write the steps. I'm going to speak the steps, say the steps, and I'm going to do the first step is draw the sketch. There is no need to draw the sketch. Sketch is already there. The second step is to draw the free body diagram. Let me draw the free body diagram. What are the elements in this free body diagram? The first thing is the weight of the block, which is 100 newtons. I've drawn it downwards. Then there would be a normal reaction coming from the ground, yes or no? And there is this force which is already there. So this is the free body diagram of the body. I'm done with step number 2, drawing the free body diagram. Now, I have to move on to step number 3. And what is step number 3? Step number 3 is that I have to choose convenient axis. Now, what is the convenient axis? Whenever something is kept on a floor, horizontal floor, or something is hanging from something, the most convenient axis that you can choose is, you can choose the vertical axis as your y-axis, and you can choose your horizontal axis as your x-axis. This is the most convenient way to do this. So I've chosen my x and y-axis. Now I can see my normal reaction is going along y-axis, no problems with that. I can see that my weight 100 Newton is going also along y-axis, no problems with that. The only thing that is going a bit slanted is the force 50 Newton. So I'm going to resolve this force into two components, and you know how to resolve it. So what is the component along x-axis? It will be 50 cos 37, 50 into 4 by 5. So that will give me 40 Newtons, yes or no? And this would be, this component will be f sine 35, sine 37. Sine 37 is 3 by 5. 50 multiplied by 3 by 5. This would be 30 newtons. So 30 newtons in the y direction and 40 newtons in the x direction. Everyone understands this? Now we come to the last step. We have to write the equations. Now this block is not going to go in air. So this block is going to move along this line. So I write it's going to move along this line. Let us say that the acceleration here is a. You can also write it as ax, doesn't matter. The acceleration here is a. Now remember, it is not going to move up and down. It is not going to move up and down. That means in the up and down direction, the forces must equate because it is in equilibrium along the up and down direction. Do you understand this? It is an equilibrium along the up and down direction. That means the forces along the up and down direction are going to equate. What are the forces in the up direction shall be equal to the forces in the down direction. So you cannot tell me the equation for the y-axis. We don't require this equation here. but we'll be requiring it in the time which that is coming up. What is the equation along y-axis? The green equation. Can anyone tell me the green equation? It's not going to move like this. Dung, 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 dung. Can you tell me what is the green equation? No one? And upwards plus 30 upwards shall be equal to 100, which is downwards. From here, you can get the value of normal reaction. Normal reaction is going to be 70 newtons. Do we understand this? It's not going to move along y-axis. So along y-axis, I'm applying the equation of equilibrium. Forces in the upward direction should be equal to the forces in the downward direction. Now we look at the equation along x-axis. What is there along x-axis? You can see there is a force 40 Newton along x-axis in the forward direction. There is no force behind here. So the net force is 40 Newton in the forward direction. It has to move in the forward direction. What is the net force in the forward direction? Can you tell me the equation for this pink direction, which is the x direction? So the equation would be force is 40 Newtons. That must be equal to m into a. M is given as 10 kg. So your acceleration becomes 4 meter per second square. And that is the answer that we were looking at. They can also ask you what is the value of normal reaction. I've also got the answer for the normal reaction. It is 70 newtons. The acceleration of the body is 4 meter per second square. Do we get this, everyone? How many of you got this answer? Great. Since we have made a good beginning, let me now present to you the next question. And don't worry, all the questions are to be done in this way. As we move ahead, instead of one block, you might have 2 blocks, 3 blocks, 5 blocks, 10 blocks. Doesn't matter. The same thing has to be applied there. Let us move on to the next question. Meanwhile, you can note down the solution of the previous one if you want to. So, this is the next question, which is question number 2. Now, what I've done here is I've placed the block of 5 kg on an inclined plane, and this inclined plane is smooth. There is no friction. Can anyone tell me what is going to happen to this body? Yes? It's going to move down, yes? Yes or no? It will slide down and it will have some acceleration. Everyone understands that the acceleration would be like this. Let us say that the acceleration is A. Can you tell me what is the value of this A? What is the acceleration of this block which is kept on an inclined plane? The inclined plane is smooth, frictionless. Friction is going to come in the next chapter. You have 2 minutes to do this.
Sir, 5 meter per second square. Sir,
Meter per second square. Okay. Anyone else with any other answer? Good. How did you get it? Everyone got it? Let me give everyone a chance. Let me give everyone a chance to get the answer. Shall I do it? How are we supposed to do this? First step, draw the sketch. Sketch is already there. Second step, draw the free body diagram. Let me draw the free body diagram. This weight is 50 newtons. This normal reaction is like this. Now for this block, you can see this. I've drawn the free body diagram. For this block, what are the convenient axes that I must choose? There is no point of choosing upward and horizontal as this because it is not moving like that. So the best way to choose an axis would be you must choose this as your x-axis and this as your y-axis. Yes or no? We understand this? Once you get this, you understand that n is always along the, it is normal, it is always along the y-axis, but this weight is going a bit on the other direction. So we have to resolve the weight. I have told you how to resolve it. This component will become mg sine 30. Yes or no? Sine 30 is half, mg is 50, so this becomes 25 newtons. And this component becomes mg cos 30. Cos 30 is root 3 by 2. This becomes 25 root 3. I'm done with the second step. Now is the third step or fourth step, whatever you call it. I have to write the equation of this block. Now you can understand that this block is not going to move like this. There's no motion along the y-axis. So now you can tell me the equation along y-axis. What will be the equation along y-axis? Your n will be equal to 25 root 3. This is the force exerted by the block on the surface or the surface on the block. Everyone understands this? The next equation I have to make is the equation along x-axis. I will call it the pink equation. The pink equation along x-axis, you can see there is 25 Newton force along this, but you don't see any force on the back side. Doesn't matter. Let us write the equation for this one. 25 in the forward direction, so it will move in the forward direction. 25 should be equal to 5 into A, where A will become 5 meter per second square. This is the answer that we were looking at. The answer is 5 meter per second square. Anyone understands this? Now remember, once you have done this question, you don't have to do it again. You can do it in a general way. What do you mean by a general way? For example, if I place a block on an inclined plane, the mass of the block is m. Now, when they ask question in a JEE, they don't ask the question straight away. They ask the question in different ways. They might give you a diagram like this, and they might ask you, on what factor does the acceleration of this block depend on? Then they might give you options. Number A, depends on the mass of the block. Number 2, it depends on the angle of inclination theta. What all factors does it depend on? So if you can just remember how we have done it generally, you would be able to understand what questions can come and what could be the answer to this question. If I again solve it in the same way, you will see that if I call the acceleration due to gravity as g, you will see that the acceleration of this block, which is obviously downwards, will come as how much? It will always come as g sine theta. That means it does not depend on the mass of the body. Whether it is 10 kg or 50 kg or 30 kg, the answer will always be g sine theta. This is the general result for a block kept on a smooth inclined surface, the angle of inclination of which is theta. Remember this, you don't have to do it again, just remember this. Now, if you compare it, I compare it with what? If I compare it with a body or block which is falling straight away downwards, its acceleration is g. If it is falling from an inclined plane downwards, smooth inclined plane, the acceleration is g sine theta. Here also, in this question, in this answer, If I put the value of theta as 90 degree, this question becomes this question and the answer becomes G. Do we understand this? So if you understand one, you understand the second one. I'm going to give you these general cases in friction also. This is a general case. I have seen many questions come on this type of cases, and that is why I am doing this. So far, so good? Yes or no? Now, obviously, the questions of one block would be very few, but most of the questions that you will encounter would be made up of more than one blocks. Let us go about and start with multiple blocks. So now let me draw a diagram of a two block system, M1, M2, and I apply a force F here. Now remember, I am not giving you the values of this F and M1 and M2 because I want to do every question in general sense. You understand the meaning of general sense? Rather than using values, let us put this as M1 and M2. So it is easier for you to understand or remember M1, M2 in terms of M1 and M2. So I may not give you the values of forces. I can just give you the question like this. Now remember, whenever such question comes, remember these two blocks are going to move together, right? They cannot get separated. So the question would not say this, but you'll have to understand that the blocks will not get separated. Now, what are the things that can be asked here? The first thing that can be asked here is what is the acceleration of the blocks? Will the block have same acceleration or different acceleration? You would have the same acceleration because they have to remain in contact. So that is the first question that they can ask. What is the acceleration of the blocks? The second question that they can ask. What is the second question that they can ask? The force between the two blocks. Remember, these two blocks are in contact. Do we understand this? So they are exerting forces on each other. Yes or no? That is the next question that they can ask. What is the force between the two blocks? I'll give you 2 minutes to solve this one. Sorry, Bacha, I'm not able to hear you. I'm not able to hear you. Still not. Everyone has solved this? Yes? Or no?
A equals to F by M1 plus M2.
That is correct. And what about the force between the two blocks? What about the force between the two blocks?
A into M1 plus M2.
No, that is not correct. I'm asking about the force between the two blocks. This is not what you said. Okay. Do you want me to do this? Do you want me to do this or are you trying? Okay. Let me help you in solving this. How are you supposed to do this? The first step is draw the free body diagram. The free body diagram is already there. Don't have to draw it. The second, the sketch is already there. Don't have to draw it. The second step is to draw the free body diagram. So here comes M1 and here comes M2. Now let me draw the free body diagram. This would be M1G. This would be normal reaction N1 because it is mass M1, so I'm calling the normal reaction as N1. Now, what are the other forces acting on this? A force F is like this. Now, instead of drawing it like this, let me draw it like this so that it looks in the direction of positive x-axis. So I draw it like this. Is there any other force acting on this block? M1 and M2 are also in contact. So M1 is pushing M2 and M2 is pushing M1. When M2 pushes M1, this force will be in the backward direction. Yes or no? So let me call that force as R. So R is the force between M1 and M2, force applied by M1 on M2 or force applied by M2 on M1. Do we understand this? Let me draw the free body diagram of M2. So M2G is here, N2 is here. Is there any other force here? Remember, M2 has applied a force on M1. So M1 will also apply the same force, but in the opposite direction. So this is the direction, or this is the free body diagram of M1 and M2. Do we all understand this diagram? Now let us make the equations. Let me first make the green equation. Is this block going to move up and down? No, it is not going to move up and down. So from this, you will get one green equation. This green equation would be N1 equals to M1G. We don't require it now, but after some time we would require it. Now, these two blocks are going to move forward with the same acceleration, yes or no? So I write the acceleration. The acceleration of this block is going to be A. The acceleration of this block with the direction will be going to be A also. Now I look at the x-axis equation of the block 1. Let me call it the blue equation. F is forward, R is backward, and acceleration is forward. Can you tell me what will be the blue equation? R is forward, sorry, F is forward, R is backward. What is the blue equation? And remember, acceleration is forward. Yes.
F minus R is equal to M1A.
F minus R will be equal to M1A. Let me call this as equation number 1. Let me now move on to this yellow equation. This block is also not going to move like this. I can write the yellow equation. What will be the yellow equation?
N2 is equal to M2G.
So we don't need it here, but after some time we would be needing it. Then we will see. Anyway, let us now come to the equation which matters. Let me call it as the whatever color this is, brown equation. R is forward, there is nothing on the backward side, and acceleration is forward. What will be this equation?
R is equal to M to A.
Let me write it with the writing. R is equal to M to A. Let me call this equation as equation number 2. Now I can simply add equation number 1 with equation number 2. R will get cancelled and I will get the value of acceleration. Can anyone tell me what is the value of acceleration?
F by M1 plus M2.
From equation number 1 and equation number 2, I can get the value of F upon M1 plus M2 will be equal to A. Now I can put this value of A in any of the equation and I will get the value of R. The simplest way is just put the value of A here and get the value of R from equation number 2. So what is the value of R coming as? You can put the value of A in equation number 2 and get the value of R. What is the value of R coming as? It will come as F into M2 divided by M1 plus M2. Do we understand this? This will be the force between the two blocks. Everyone understands this? Yes or no? I'll give you 2 minutes to note this down. If you have any doubt, please ask. Have you noted it down, bacha? Can I give you a next problem? Okay. Let me now introduce, instead of 2 blocks, let me introduce a system of 3 blocks. And then we will try to make some sense here. Now I have 3 blocks, M1, M2, and M3. And I apply a force F here. Again, I ask you the same question, beta. What is the acceleration of the blocks? And what is the force between the blocks? There are 2 forces now. One is between M1 and M2. The other one is between M2 and M3. Can you tell me the answer for this? I'll give you 2 minutes to do this. Can you tell me?
Sir, acceleration is equal to F.
I can't hear you.
Acceleration is equal to F by M1 plus M2 plus M3.
Yes, I know that you know how to find out the acceleration. Can you tell me the forces? Okay, I'll give you 2 minutes. Think about it. How do you get the forces between the two blocks? Okay, how do you find out the forces between the two blocks? Now, anyone, any idea? Okay, let me start with the very basic, and then I will try to make some sense to tell you how you can do it.
Sir,
Fast.
acceleration is equals to F plus R by M1 plus M2 plus M3.
Acceleration is F upon M1 plus M2 plus M3. Yes, that is correct, beta. What about the forces between the two blocks? How will you get the forces between the two blocks? That is what I was asking. Let me do it once more, and then probably I'll try to make more sense. Let me do it fast. This is M1, this is M2, this is M3. M1, M2, M3. Let me draw the free body diagram. M1G, N1, the force is F. Everyone sees this, yes or no? But there will be a reaction force between M1 and M2. It will be going back. Let me call it as R1. Let me draw the free body diagram of M2. This is M2G. This is N2. This R1 force is coming because of mass 1. And this R2 force will be coming because of mass 3. Do we understand this? M3G, N3. And on N3 and on M3, there is only one force, which is R2. Do we understand this? Now, let me not write the equation in the up and down direction. We know all the equations in the up and down direction. N1 will be equal to M1G, N2 will be equal to M2G, and N3 will be equal to M3G. Let me write the pink equation of this block. Now, remember, all these three blocks should be moving forward with the same acceleration A. Yes or no? So, can you anyone tell me what is the pink equation of this first block? I'm not writing the y equation. Yes, can you tell me what is the first equation? F minus R1 will be equal to M1A. Do we understand this? Yes or no? Let me write the second equation of the green block. R1 is forward, R2 is backwards, acceleration is forward. What is the green equation? Forward is R1 minus reverse is R2. It is equal to M2 into A. Let me move on to the third one, the blue block. Blue block only has R2 here. I can write the value of R2 as M3 into A. Now, if I combine all these three equations together, I should get the value of the acceleration of the block. And the value of the acceleration of the block will come as F upon M1 plus M2 plus M3. Now, having understood this question and the previous question, we can understand that there is a general thing happening. What is that general thing which is happening here? In this question or in the previous question, all the blocks were moving with the same acceleration. Yes or no? They were not moving with different acceleration. They were moving with the same acceleration, and also they were moving in the same direction. So instead of doing all this is the correct way of doing it. Instead of doing all this, you can straight away write the acceleration of the three blocks. You can write the acceleration of three blocks without doing all this. If you understand it, you can write the equation of, you can find out the acceleration of the three blocks by simply dividing the total force or the net force divided by the total mass. Do we understand this? Everyone? I don't see boys. Everyone understand this? Okay. Now, the other way to understand this in a different way is this. Now listen to me very carefully. Now, since all the three blocks are moving together, they are just like one block, basically. To just find their acceleration, what I can do is shortcut. I can take these three blocks as one system. The net external force on this system is F. Do we understand this? And the total mass of this block is M1 plus M2 plus M3. Do we understand this? So I can find out the acceleration of these three blocks by total force divided by total mass, F divided by total mass. Total mass is M1 plus M2 plus M3. Do we understand this? Yes or no? The first way of finding out the acceleration. So unless and until the blocks will move with different acceleration, you can always find the acceleration with this concept. We understand this, whether there are three blocks or 4 or 5 or 6 or 10. Anyone understands this? Now the only thing that we have to understand is, how do I get the value of this R2 and R3? Can R2 and R1, can I apply a similar concept and get the value of R1 and R2 also? Now, to get the value of R3, to get the value of R2, R2 is very simple. You can see this. To get the value of R2, what do? You take only block M3, the last block. You only take the last block and multiply M3, the last block of mass, by the acceleration. This acceleration you have already calculated, so straight away you will get the value of R2. Do we understand this? So you get the value of R2 from the last block. The only thing that remains now is to find out the value of R1. How do I get the value of R1? To get the value of R1, what you can do, bacha, if you understand it, you can take, and I'm going to do it. You can take M2 and M3 as one system. You can take M2 and M3 as one system. Now, if you take M2 and M3 as one system, what happens, bacha? This R2 which is the internal force, will get cancelled. And the only force that remains is R1. So you can write, since you have taken two blocks as one system, you can write R1 as M2 plus M3 multiplied by A. And you have already calculated the value of A. So now, if I condense everything together, to get the value of A, what do I do? Total force on the three blocks divided by the mass of the three blocks. To get the value of force between M1 and M2, I take M2 and M3 as one system. So R1 becomes M2 plus M3 multiplied by A. To get the value of R2, I only take M3 as the block. Value of R3 is M3 multiplied by A. Do we understand this, or this has gone above or saying bye-bye? Bye-bye. See, I've told you the actual procedure. This is the actual procedure. But if you are smart enough, JEE is about doing things fast. If you are smart enough, you can do this question quickly without writing all these equations. Do we understand this? In the next class, we will do more problems, and if you understand this concept, the simpler problems you will just do in 1 or 2 or 3 or 5 seconds. The only problem you will face is that when the blocks will move with different acceleration, then only you will face some trouble. No trouble, then you have to do the problems with the original tariqa. This way is applicable only and only when the blocks are moving with the same acceleration. Do we understand this? When they move with the same acceleration, you can apply this. If they move with different acceleration, you know the original way. You can apply that original way, get your answer. And
Excuse me, sir.
Yes, beta.
Sir, can you say tomorrow's portion for exam?
Everything. Exam always has everything. Everything meaning from the first chapter till today's class. Not today's class.
Okay, sir. Thank you.
Always be prepared for exam. Always be prepared with your entire topic. I can give question from anywhere. That is how you prepare for exam. You don't just prepare your current topics. Current topics, everyone is champion. Everyone knows the current topics. But to become good, you must know everything. So sometimes I might surprise you and only give current topic. That's surprise. So every test for you is a surprise test. Sometimes you might only find one topic and the rest of the topics will go bye-bye. And sometimes you will find all topics. And sometimes your current topic will be missing completely and the past of the topics will come. Good, na? In this way, this habit of your revision will go away. Because what will you revise? Everything is coming at you. Revise everything. Revise everything. So that is good. Right? So that is my way of teaching you that you must be prepared for test at all times. Do we understand this? It may happen that the older topics may have only 1 or 2 questions. It may happen. It may happen that the newer topics will have more questions. It may also happen that the newer topic will already be gone, 0, and everything will come from the older topic. Anything can happen. Life is a surprise. Be ready to be surprised. Okay? So every day, every week, test contains everything. Bye-bye. Take care. God bless you.
Thank you, sir.